Hello everyone, hello my lovely students. Welcome back to this video session. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got an amazing math lesson for you all. Want to know what's that? Then please don't skip and make sure you stay with me till the end. Here we go. So for today, we're going to talk about trigonometric identities and we'll solve some questions based upon those identities. So the first identity that we use very frequently in trigonometry is sine square of alpha plus cos square of alpha is equals to 1. This is the first one we use very frequently. Most of the time you'll see that we can also write cos square alpha is equals to 1 minus sine square alpha, or we can write sine square alpha is equals to 1 minus cos square alpha. The second identity that we use very often is sec square alpha minus tan square of alpha is equals to 1. We can also write it as sec square alpha is equals to 1 plus tan square alpha, or we can write it as tan square alpha is equals to sec square alpha minus 1 by rearranging the terms. And the last one is, and the third one is cosec square alpha minus cot square alpha is equals to 1, which can also be written as cosec square alpha is equals to 1 plus cot square alpha, or cot square alpha is equals to cosec square alpha minus 1. So you have to memorize all these three in their original form. Okay. The other form that we express that can be expressed at the time of solving questions, but this three is the base form. You have to memorize all these three identities in their original form. All right. There are a few more concepts as well that we have to memorize for solving questions, and they are very important. Like perhaps many of you might be knowing that in advance. Sine of alpha by cos of alpha is your tan alpha. This is also very important and we use very frequently, and mostly when it comes to proving questions. If you reciprocate both sides, you do the reciprocal of both sides, you get cos alpha upon sine alpha is equals to cot alpha. Then we have reciprocal relationship between the trigonometric ratios, like you must be knowing that sine alpha is equals to 1 by cosec alpha. Then we have cos alpha, which is equals to 1 by sec alpha. And lastly, we have cot alpha, which is equals to 1 by tan alpha, or you can say tan alpha is equals to 1 by cot alpha. For this as well, you can write cosec alpha is equals to 1 by sine alpha, and or you can write sec alpha is equals to 1 by cos alpha, depending on the situation. Let's solve the first question of today's session. We have sec theta plus tan theta is equals to 4. Then we have to find the value of sine theta. Now there are two different approaches for this question. First, I'll tell you that way which most of the students prefer, and the second one is a much smarter way. We'll also talk about that. But let's solve this question using the first one, which most of the students prefer. So we have sec theta plus tan theta is equals to 4. And because we want to find the value of sine theta, we can express the given trigonometric ratios in terms of sine and cos by using the formula that we have just studied right now a couple of moments back. So for sec theta, we can write 1 by cos theta, and for tan theta, we can write sin theta by cos theta. If we rearrange the terms and take the LCM, we get 1 plus sin theta by cos theta is equals to 4. Let's do the cross multiplication. Okay, if we cross multiply, we get 1 plus sin theta. Okay, just let me make the boundaries. We get 1 plus sin theta is equals to 4 cos theta. Alright, now we can do the squaring of both sides. Why we do the squaring, you will understand in a short while. So squaring, we get 1 plus sin theta whole square is equals to 4 cos theta square. Okay, we use the identity a plus b whole square and we expand. So we get 1 plus sin square theta, and 2ab is your 2 sin theta. Then we have 16 cos square theta. Now in place of cos square theta, we can write 1 minus sin square theta using the identity. If you use this identity, sin square theta plus cos square theta is equals to 1, then cos square theta can be written as 1 minus sin square theta. Okay, so just we'll write here 1 plus sin square theta plus 2 sin theta is equals to 16 times 1 minus sin square theta. If you open the bracket, we get 1 plus sin square theta plus 2 sin theta is equals to 16 minus 16 sin square theta. Now for simplification, for the ease of solving, we can replace sin theta by s. So we have 1 plus s square plus 2s is equals to 16 minus 16 s square. Okay, then we have 17 s square plus 2s minus 15 is equals to 0. Now using the middle term splitting method, we can factorize this. And we'll get the factor as 17s square, and this will be your 17s minus 15s minus 15 is equals to 0. If you take 17s common, you're left with s plus 1. Then you take minus 15 common, s plus 1. You can take s plus 1 common, and then you are left with 17s minus 15 is equals to 0. So this means s plus 1 is equals to 0, or 17s minus 15 is equals to 0. S is equals to minus 1, or s is equals to 15 upon 17. S is actually your sin theta. So you have sin theta is equals to minus 1, or sin theta is equals to 15 upon 17. This is wrong. Why? Because it is given to us that theta lies between 0 to 90 degree, and all the trigonometric ratios, when the angle lies between 0 to 90 degree, they are all positive. So all t of theta is positive when theta lies between 0 and 90 degree. T for all the trigonometric ratios, sine, cos, tan, cosec, sec and cot. So when the angle lies between 0 and 90 degree, all the trigonometric ratios are positive. So it is given in the question. So for that reason, we cannot accept this solution. So sin theta is equals to 15 upon 17. This is the right answer. Now we'll talk about the second way. We have sec theta plus tan theta is equals to 4. So unlike the previous way where we have expressed sec and tan in terms of sine and cos, we're not going to do anything like that. We'll use the identity. So can you guess what's the identity we're going to use? Many of you would have got the answer. Yes, we are going to use sec square theta minus tan square theta is equals to 1. Okay, this can be written as, now it looks somewhat like a square minus b square. Don't you see? It looks somewhat like a square minus b square. So a square minus b square can always be written as a plus b into a minus b. So for this we can write sec theta plus tan theta into sec theta minus tan theta is equals to 1. Now you all must be knowing that in maths, when the multiplication of two quantities results in 1, then they are reciprocal of each other. So the value of sec theta plus tan theta is equals to 4. So if this value is 4, then this has to be 1 by 4, then only we can get 1. So using this identity, we have got two equations. The first one is already given to us, and the second one we get sec theta minus tan theta is equals to 1 by 4. This is the second one. Now what we are going to do with these equalities, you'll just know in a short while. We have to find the value of sine theta. Now for sine theta, I can express it as sine theta by cos theta into cos theta. Is there any problem? I hope so, no. Why? Because see, cos theta and cos theta is actually cancelling out and we are left with sine theta, the one that we have in the left hand side. So these are actually the same thing, only we have written in a different way for the ease of our answer. So this sine theta by cos theta is tan theta, and if we bring this cos theta in the denominator, we have 1 by cos theta, which actually comes out to be tan theta upon sec theta. So sine theta is tan theta by sec theta. Now we'll solve these two equalities and get the values of sine, tan and sec. So if we add these two equalities, 1 plus 2. So on the left hand side, we'll get 2 sec theta is equals to 4 plus 1 by 4. So this will be your 17 by 4. So 2 sec theta is equals to 17 by 4, which means sec theta is equals to 17 by 8. Now for tan theta, we can subtract the two equalities, or we can put the value of sec theta in any one of the equalities to get the value of tan theta, but I'll prefer subtracting. So if I subtract the two equalities 1 minus 2, so we have 2 tan theta on the left hand side, and on the right hand side we have 4 minus 1 by 4. So we get 2 tan theta is equals to 15 upon 4, which is actually giving us tan theta is equals to 15 upon 8. Now we can put the values in the here we can put the values. We have sine theta is equals to tan theta upon sec theta. The value of tan theta is 15 by 8, and the value of sec theta is 17 by 8, which comes exactly the same like the previous method that we have solved. That's all. So coming back to the last question of today's session, it's actually a proof. We have to prove that the square root of 1 plus cos A upon 1 minus cos A is equals to cosec A plus cot A. Okay, so there are two ways. Either we can simplify the left hand side expression to get the right hand side, or we can simplify the right hand side expression to get the left hand side. Usually we prefer that expression for the simplification that looks a little more complicated. So in this case, you can see the left hand side expression, it looks a little ugly and complicated because we have a square root sign here. So we'll prefer the simplification of left hand side expression. Let's start. So left hand side expression, we have the square root of 1 plus cos A upon 1 minus cos A. Now to get the idea of how to simplify these square root expression, you see the right hand side expression, there is no square root sign. So we have to make this expression free from a square root. And how we make an expression free from a square root, perhaps you must be knowing that. I'll give you a little idea. Let's say if we have p square in the square root, then we can write it p. If we have p plus q whole square in the square root, we can write it as P plus Q. Or if we have P plus Q by R whole square, we can write it as P plus Q by R. So the idea is, if the expression inside the square root looks somewhat like this, so we can write it as something. Something can be any expression, algebraic expression or trigonometric expression. So hope you understand this. Now we have cosec A plus cot A. So just for getting an idea of how to simplify the inside expression of a square root, we can think of cosec A as 1 by sine A and cot A as cos A by sine A, which can also be written as 1 plus cos A by sine A. So this gives us an idea that if somehow this inside expression of a square root, if we are able to write it in this form, 1 plus cos A upon sine A whole square, then at the end we can write 1 plus cos A upon sine A, and this will eventually give us cosec A plus cot A. So I tried my best to make you realize what we're actually going to do for this question. Okay, so because in the denominator in the numerator we are getting 1 plus cos A square, so this gives me an idea that I should multiply the numerator and the denominator by 1 plus cos A. So if we do that, the denominator will already be sorted. So in numerator I am getting 1 plus cos A whole square, and in the denominator we see A minus B into A plus B, which actually will give us A square minus B square. So A square means 1 square, which is actually 1, and B square we have cos square A. Now here we can use the identity sin square A plus cos square A is equals to 1. So sin square A is equals to 1 minus cos square A. So in place of in place of 1 minus cos square A, I can write sin square A. So we have 1 plus cos A whole square, and 1 minus cos square A is your sin square A. Now further simplification, we can write 1 plus cos A upon sine A whole square. Now this can be taken outside the square root now. Just I told you about all these. So if you take out this from the square root, it will come 1 plus cos A upon sine A, and if we segregate this, it will be 1 by sine A plus cos A by sine A. Now 1 by sine A is your cosec A, and cos A by sine A is your cot A, which is equals to the RHS, and we did it. That's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all, my lovely friends, in my next upcoming videos with more exciting and awesome questions. Till then, bye bye, stay safe and have a nice day.